Katie is catering an event this weekend and needs to begin prepping. There are 170 guests scheduled. On the menu is chicken, salmon, and vegetarian. Although people often do not have a preference of fish and chicken, she is concerned about having enough vegetarian dishes. We know about 7% of the population is vegetarian. Just making 7% of the meals may not be enough. There's still a high chance of running out of vegetarian meals. She wants to ensure that the probability of running out is very low. She's taken a statistics course, so she knows that there's some random chance, right? Maybe more vegetarians, maybe less. It's not always going to be exactly 7%. Why is this a binomial distribution? Why can a binomial model help us make this prediction? Okay. So first of all, we need to have binary. So we know it's binary because each guest at her wedding would either be a vegetarian or not be a vegetarian. So there are exactly 2 outcomes. You are either a vegetarian or not a vegetarian. Okay, so that's why it's binary. There are exactly 2 outcomes. You're either a vegetarian or not a vegetarian. I know that there are more than just 2 options for meals, but if we change the options to either vegetarian or not vegetarian, we can use this binomial model. Next, independent and identical trials. Each trial has the same probability of success. They're independent of each other. So let's assume that each guest decides to be vegetarian individually. So one guest randomly pick has no effect on the next guest. Now, this is maybe not 100% true because maybe if you have a pair of friends that are in a relationship together, if one is a vegetarian, maybe there's a higher chance that the other one is vegetarian. But if we're just randomly picking guests and Katie is having 170 guests, then it's okay to think of this as a random event, that the probability will always be, there's about a 7% chance that every guest is vegetarian. Now, what I mean is that since there's 170 guests, since our sample size is 170, this 5% rule means that 170 times 20 equals 3,400 people in the population that we have independence, that it's okay to sample without replacement, that there's 3,400 people, at least 3,400 people in the population. The number of trials is fixed, yes. The n in this problem equals 170 guests is fixed. They will have exactly this number of guests. So n in this problem is 170. P is the probability of success, which is 0.07. Q is 0.93, the probability that you aren't a vegetarian. So that is the probability of failure. It just wants to know, have you identified the variables? And then you can see the answers here. Each trial can be divided into vegetarian meal or not vegetarian. Thus, it's binary. Even though a person may order chicken or fish, given a total of 3 options, we can lump both of those options into a single failure outcome, that those people are not vegetarians. We can assume the probability for each person ordering a vegetarian meal is 0.07. It is reasonable to assume that 170 guests attending the event is less than 5% of the entire population, so it's reasonable to assume the probability for each trial is independent, that I can sample without replacement. There are 170 guests, so the number of trials is 170.